Hello friends, today I am discussing about the most important chapter of science class 8th, from which minimum 2 to 4 questions are asked in every exam, so it is most important. So let's start without wasting of time. Chapter number is 8. Chapter name is Force and Pressure. In class 7, you have learned how objects move. Do you recall how we can decide whether an object is moving faster than the other? What does the distance moved by an object in unit time indicate? What? You also know that a moving object like a ball rolling on the ground slow down sometimes it may change its direction of motion. It is also possible that the ball may slow down and also change its direction. Have you ever wondered what makes an object slow down or go faster or change its direction of motion? यहाँ पे बताया गया है कि आपने नोटिस किया होगा, जब आप किसी भी ऑब्जेक्ट को या किसी बॉल को आप किसी फील्ड पे यदि फेंकते हो तो कुछ देर के बाद क्या होता है, वह बॉल धीरे धीरे अस्थिर हो जाता है. गॉट इट? और इतना अस्थिर हो जाता है कि एक समय के बाद वो रुक जाता है और अपना डायरेक्शन भी वो बॉल चेंज करते रहता है. गॉट इट? तो यह क्यों होता है, इसी के बारे में आज हम सीखेंगे. क्या होता है फोर्स? गॉट इट? क्या होता है डायरेक्शन? क्या होता है प्रेशर? इसी के बारे में आज हम जानेंगे. नेक्स्ट, लेट अस रिकॉल some of our everyday experience. What do you do to make a football move? What do you do to make a moving ball move faster? What? How does a goalkeeper stop a ball? What? A hockey player changes the direction of the moving ball with a flick of the stick. How do fielders stop a ball hit by a batsman? What? Figure 8.1. In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown or flicked. What is a force? What can it do to bodies on which it is applied? What? We shall seek answer to such questions in this chapter. Force, a push or a pull. Action like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the state of motion of an object. Got it? यहाँ पे जो भी एक्शन हो रहा है, लाइक पिकिंग, ओपनिंग, शटिंग, किकिंग, हिटिंग, लिफ्टिंग, थिकिंग, फ्लिकिंग, पुशिंग, पुलिंग, ये सभी जो हैं, ये सभी टास्क जो हैं, यहाँ पे कुछ ना कुछ एक्शन हो रहा है और कुछ ना कुछ रिजल्ट आ रहा है. ये जो चेंजेज हैं, इसको हम क्या कहेंगे? मोशन ऑफ एन ऑब्जेक्ट, किसी भी वस्तु की गति को बढ़ाना, घटाना। गॉट इट? कैन these terms be replaced with one or more terms? What? Let us find out. Here, figure 8.1a, a goalkeeper saving a goal. B, a hockey player flicking a ball. And C, a fielder stopping a ball. यहाँ पे एक गोलकीपर क्या कर रहा है? बॉल को गोल कर रहा है, गोल होने से बचा रहा है, सेविंग और गोल। गॉट इट? जो अपोजिट वाले फील्डर हैं वो गोल करना चाहते हैं, उससे उसको क्या कर रहा है? बचा रहा है। ये हॉकी प्लेयर क्या कर रहा है? बॉल को फ्लिकिंग कर रहा है। एंड अ फील्डर स्टॉपिंग अ बॉल, जो सी नंबर में है वो क्या कर रहे हैं? बॉल को रोक रहे हैं। गॉट इट? नेक्स्ट एक्टिविटी 8.1, टेबल 8.1 गिव some example of familiar situation involving motion of object. You can add more such situations or replace those given here. Try to identify action involved in each case as a push and or a pull and record your observation. One example has been given to help you. Got it? यहाँ पे एक एग्जाम्पल फुलफिल कर दिया गया है, बाकी को बोल रहा है खुद से फुलफिल करने के लिए, तो आप इसको देख सकते हैं। गॉट इट? नेक्स्ट, डू यू नोटिस दैट ईच ऑफ द एक्शन कैन बी ग्रुप्ड एज अ पुल और अ पुश और बोथ? व्हाट कैन वी इन्फर फ्रॉम दिस? दैट टू मूव एन ऑब्जेक्ट it has to be pushed or pulled. What? In science, a push or a pull on an object is called a force. साइंस की भाषा में, विज्ञान की भाषा में बोले तो यदि हम किसी भी वस्तु को पुश करते हैं, धकेलते हैं, और पुल करते हैं, खींचते हैं, तो यह क्या कहलाएगा? फोर्स कहलाएगा। गॉट इट? 10, we can say that the motion imparted to objects was due to the action of a force. When does a force come into play? What? Let us find out. Got it? Here, I learnt in class 6 that a magnet attracts a piece of iron towards it. Is attraction also a pull? What about repulsion between similar poles of two magnets? What? Is it a pull or a push? What? ये पूछा जा रहा है, ये बच्ची पूछ रही है कि मैंने 6th क्लास में पढ़ा था कि मैग्नेट जो है किसी भी आयरन के पीस को अपनी ओर आकर्षित करता है, खींचता है, तो इसको हम क्या कहेंगे? पुल कहेंगे। इज अट्रैक्शन आल्सो अ पुल? व्हाट? खींचना कहेंगे। व्हाट अबाउट रिपल्सन बिटवीन सिमिलर पोल्स ऑफ टू मैग्नेट? जब किसी भी मैग्नेट, चुंबक के सिमिलर पोल होते हैं, नॉर्थ नॉर्थ, साउथ साउथ, तो एक दूसरे को रिपेल करते हैं, तो यहाँ पे क्या कहेंगे? इज इट अ पुल और अ पुश? ये बच्ची पूछ रही है। गॉट इट? नेक्स्ट, फोर्स आर ड्यू टू एन इंटरेक्शन. सपोज अ मैन इज स्टैंडिंग behind a stationary car. Figure 8.2a. Got it? Will the car move due to his presence? What? Suppose the car now begins to push the car. Figure 8.2b. That is, he applies a force on it the car may begin to move in the. Got it? Figure 8.2a, a man standing behind a stationary car. Okay. Next, a car being pushed by a man. यहाँ पे एक व्यक्ति ये कार को धक्का लगा रहे हैं. Direction of the applied force. Note that the man has to push the car to make it move. Next, figure 8.3a, who is pushing whom. यहाँ पे पूछा जा रहा है कि कौन दूसरे को पुश कर रहा है, मतलब धकेल रहा है इस फिगर में. गॉट इट? फिगर 8.3 शो 3 सिचुएशन दैट मे बी familiar to you. Can you decide who is pulling and who is pushing in these cases? What? In figure 8.3a, both the girls appear to push each other while. 8.3 figure, who is pulling whom. ये पूछा जा रहा है कि इसमें से कौन एक दूसरे को खींच रहा है. द पेयर ऑफ गर्ल्स इन फिगर 8.3b आर ट्राइंग टू पुल इच अदर. यहाँ पे जो है दोनों गर्ल्स एक दूसरे को अपनी ओर खींच रही है. गॉट इट? सिमिलरली द कॉ एंड द मैन इन फिगर 8.3c अपियर टू पुल इच अदर. ठीक उसी प्रकार यहाँ फिगर 8.3 में एक गाय और एक मनुष्य एक दूसरे को खींच रहे हैं, मतलब गाय मनुष्य को खींच रहे हैं और मनुष्य जो है गाय को खींच रहे हैं. गॉट इट? नेक्स्ट, द गर्ल्स इन द टू सिचुएशंस शो हेयर आर अप्लाइंग फोर्स ऑन ईच अदर. इज इट ऑल्सो ट्रू फॉर द मैन एंड द कॉ? व्हाट? फ्रॉम these examples we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object result in a force between the two objects. Got it? Exploring forces. Let us try to learn more about forces. Activity 8.2. Choose a heavy object like a table or a box which you can move only by pushing hard. Try to push it all by yourself. Can you move it? What? No. Ask one of your friends to help you in pushing it in the same direction. Figure 8.4a here. Got it? It is easier to move it. No. What? Can you explain why? No. Push the same object but ask your friend to push it from the opposite side. Figure 8.4b. Does the object move? अब यही सेम सिचुएशन क्या करना है 8.4b में आप देख सकते हो कि एक लड़का इधर से धक्का दे रहा है और एक लड़का इधर से धक्का दे रहा है एक ऑब्जेक्ट में. गॉट इट? यहाँ पे सिमिलर एक ही दिशा में दोनों मिलके दे रहा है दिशा, लेकिन इधर ये इधर दे रहा है, ये इधर दे रहा है, मतलब अपोजिट डायरेक्शन में दे रहा है. गॉट इट? Does the object move? What? If it does not, the direction in which it moves. Can you gauge which one of you is applying a larger force? What? Next. Figure 8.4. Two friends pushing a heavy load A in the same direction, B in opposite direction. Have you ever seen a game of tug of war. In this game, two teams pull at a rope in opposite direction. Figure 8.5. Members of both the team try to pull the. Here, figure 8.5, the rope may not move if the two teams pull at it with equal force. यहाँ पे जो दो टीम है, दोनों तरफ तीन तीन बच्चे हैं. यदि दोनों टीम इक्वल फोर्स लगाए दोनों साइड से, तो ये रोप जो रस्सी है वह किसी भी साइड मूव नहीं करेगा. गॉट इट. नेक्स्ट, rope in their direction. Sometimes the rope simply does not move. It is not similar to the situation shown in figure 8.3b. What? The team that pulls harder, that is applies a larger force, finally wins the game. ये दो टीम में से जो सबसे ज़्यादा फोर्स अप्लाई करेगा वह फाइनली जो गेम है उसको जीत लेगा. गॉट इट. नेक्स्ट, व्हाट डू दीज एग्जाम्पल्स सजेस्ट अबाउट द नेचर ऑफ फोर्स? व्हाट? फोर्स अप्लाइड ऑन एन ऑब्जेक्ट इन द सेम डायरेक्शन add to one another. Now, recall what happened when you and your friend pushed the heavy box in the same direction in activity 8.2. If the two forces act in the opposite direction on an object, the net force acting on it is the difference between the two forces. What did you observe in activity 8.2 when both of you were pushing the heavy box from opposite direction? Recall that in the tug of war, when two teams pull equally hard, the rope does not move in any direction. Got it? Next. So, we learned that a force could be larger or smaller than the other or equal to each other. The strength of a force is usually expressed by its magnitude. We have also to specify the direction in which a force acts. Also, if the direction or the magnitude of the applied force changes, its effect also changes. If the direction or the magnitude of the applied force changes, its effect also changes. Got it? Next, does it mean that the net force on an object is zero if the two forces acting on it in opposite direction are equal? What? In general, more than one force may be acting on an object. However, the effect on the object is due to the net force acting on it. Next, a force can change the state of motion. Let us know. Find out what happens when a force acts on an object. Activity 8.3. Take a rubber ball and place it on a level surface such as a table, top or a concrete floor. Now, gently push the ball along the level surface. Figure 8.6. Does the ball begin to move what? Push the ball again while it is still moving. Is there any change in its speed? What? Does it increase or decrease? What? Next. Place your palm in front of the moving ball. Remove your palm as soon as the moving ball touches it. Does your palm apply a force on the ball? What? What happens to the speed of the ball? No. What? Does it increase or decrease? What? What would happen if you let your palm hold the moving ball? What? ये क्वेश्चन पूछा जा रहा है यहाँ पे. Got it? Here, figure 8.6. A ball at rest begins to move when a force is applied on it. Got it? You might recall similar situation. For example, while taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest and so its speed was 0. The applied force makes the ball move towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. Next, the force applied by him can stop or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to 0. These observations suggest that a force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. If the force is applied in the direction opposite to the direction of motion, then it results in a decrease in the speed of an object. Got it? Here, figure 8.7. To move a tire faster, it has to be pushed repeatedly. I have seen children competing with one another in moving a rubber tire or a ring by pushing it. Figure 8.7. I now understand why the speed of the tire increases whenever it is pushed. Got it? Peheli is curious to know whether application of a force can only change the speed of an object. Let us find out. Activity 8.4. Take a ball and place it on a level surface as you did in activity 8.3. Make the ball move by giving it a push. Figure 8.8a. Now place a ruler in its path as shown in figure 8.8b. In doing so, you would apply a force on the moving ball. Does the ball continue to move in the same direction after it strikes the ruler? What? Repeat the activity and try to obstruct the moving ball by placing the ruler in such a way that it makes different angles to its path. In each case, note your observation about the direction of motion of the ball after it strikes the ruler. Got it? Figure 8.8a. A ball set in motion by pushing it along a level surface, and b. The direction of motion of the ball after it strikes the ruler placed in its path. Got it? Let us consider some more examples in a game of volleyball. Players often push the moving to their teammates to make a winning move. Sometimes the ball is returned to the other side of the court by pushing or smashing it. In cricket, a batsman plays his or her shot by applying a force on the ball with the bat. Is there any change in the direction of motion of the ball? In these cases, what? In all these examples, the speed and the direction of the moving ball change due to the application of a force. Can you give a few more examples of this kind? What? Next, a change in either the speed of an object or its direction of motion or both is described as a change in its state of motion. Thus, a force may bring a change in the state of motion of an object. State of motion. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be the state of zero speed. An object may be at rest or in motion. Both are its state of motion. Got it? Next, does it mean that the application of a force would always result in a change in the state of motion of the object? What? Let us find out. It is common experience that many a time application of force does not result in a change in the state of motion. For example, a heavy box may not move at all even if you apply the maximum force that you can exert. Again, no effect of force is observed when you try to push a wall. Got it? 8.5. Force can change the shape of an object. Got it? Activity 8.5. Some situations have been given in column 1 of table 8.2 in which objects are not free to move. Column 2 of the table suggests the manner in which a force can be applied on each object, while column 3 shows a diagram of the action. Try to observe the effect of force in as many situations as possible. You can also add similar situations using available material from your environment. Note your observation in column 4 and 5. of the table. Got it? Table 8.2. Studying the effect of force on object. Description of situation, how to apply force, diagram, action of force. First, change in state of motion. Second, change in shape. गॉट इट? इसको आप एक बार गो थ्रू हो सकते हैं. गॉट इट? व्हाट डू यू कंक्लूड फ्रॉम द ऑब्जर्वेशन noted in table 8.2? What happens when you apply a force on an inflated balloon by pressing it between your palm? What happens to the shape of a ball of dough? डो मतलब आटा का जो गुथा हुआ रहता है. When it is rolled to make a chapati, what happens when you press a rubber ball placed on a table? In all these examples, you saw that the application of force on an object may change its shape. Got it? Next, having performed all the above activities, you would have realized that a force, first, may make an object move from rest, may change the speed of an object if it is moving, may change the direction of motion of an object, may bring about a change in the shape of an object, may cause some or all of these effects. While a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Thus, an object cannot move by itself. It cannot change speed by itself. It cannot change direction by itself, and its shape cannot change by itself. Got it? Now, we will discuss about contact force. कॉन्टैक्ट फोर्स के अंदर क्या आता है? मस्क्यूलर फोर्स. गॉट इट? कैन यू पुश और लिफ्ट अ बुक laying on a table without touching it? No. Can you lift a bucket of water without holding it? Generally, to apply a force on an object, your body has to be in contact with the object. The contact may also be with the help of a stick or a piece of rope. When we push an object like a school bag or lift a bucket of water, where does the force come from? This force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as the muscular force. It is the muscular force that enables us to perform all activities involving movement or bending of our body. In class 7, you have learnt that in the process of digestion, the food gets pushed through the alimentary canal. Could it be a muscular force that does it? You also know that lungs expand and contract while we inhale and exhale air during breathing. Where are these muscles located which make breathing possible. What? Can you list a few more examples of the force exerted by the muscles in our body? What? Next, animals also make use of muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys, and camels are used to perform various tasks for us. In performing these tasks, they use muscular force. Figure 8.9. Got it? Here you can see figure 8.9. Muscular force of animals is used to carry out many difficult tasks. Got it? Since muscular force can be applied only when it is in contact with an object. It is also called a contact force. Got it? Next, are there other type of contact forces? What? Let us find out. Friction. Recall some of your experiences. A ball rolling along the ground gradually slows down and finally comes to rest. When we stop paddling a bicycle, it gradually slows down and finally comes to a stop. A car or a scooter also comes to rest once its engine is switched off. Similarly, a boat comes to rest if we stop rowing it. Can you add some more such experiences? What? In all these situations, no force appears to be acting on the object, yet their speed gradually decreases and they come to rest after some time. What caused a change in their state of motion? What? Could some forces be acting on them? Can you gauge the direction in which the force must be acting in each case? What? Next, the force responsible for changing the state of motion of objects in all these examples is the force of friction. Okay. Next, it is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Similarly, friction between water and the boat brings it to a stop once you stop rowing. Got it? Next, the force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Since the force of friction arises due to contact between surfaces, it is also an example of a contact force. You will learn more about this force in chapter 9. You may be wondering whether it is essential for the agent applying a force. Got it? On an object to be always in contact with it. Let us find out non-contact force. Magnetic forces. Activity 8.6. Take a pair of bar magnets. Place the longer side of one of the magnets over three round shaped pencils or wooden rollers as shown in figure 8.10. Now, bring one end of the other magnet near the end of the magnet placed on the rollers. Make sure that the two magnets do not touch each other. Observe what happens. Next, bring the other end of the magnet near the same end of the magnet placed on the rollers. Figure 8.10. Note what happens to the magnet placed on the rollers every time another magnet is brought near it. Got it? Here, figure 8.10 observing attraction and repulsion between two magnets. Got it? ये सिमिलर पोल है तो ये रिपेल हुआ है, यहाँ अपोजिट है तो अट्रैक्शन हुआ है. गॉट इट? डज द मैग्नेट ऑन द रोलर्स बिगेन टू मूव व्हेन द अदर मैग्नेट इज ब्रॉट नियर इट? डज इट ऑलवेज मूव इन द डायरेक्शन ऑफ द अप्रोचिंग मैग्नेट? What do these observations suggest? Does it mean that some forces must be acting between the two magnets? You have learned in class 6 that like poles of two magnets repel each other. आपने क्लास 6 में पढ़ा होगा जो सेम ध्रुव होते हैं, मतलब लाइक पोल्स होते हैं मैग्नेट के, चुंबक के, तो रिपेल करते हैं ईच अदर, एक दूसरे को क्या करते हैं? रिपेल करते हैं. एंड अनलाइक पोल्स अट्रैक्ट ईच अदर. जो अनलाइक पोल्स होते हैं, असमान ध्रुव होते हैं, वो अट्रैक्ट करते हैं एक दूसरे को. अट्रैक्शन और रिपल्सन बिटवीन ऑब्जेक्ट्स कैन आल्सो बी सीन एज अनदर फॉर्म ऑफ पुल और पुश. डू यू हैव to bring the magnets in contact for observing the force between them? A magnet can exert a force on another magnet without being in contact with it. The force exerted by a magnet is an example of a non-contact forces. Similarly, the force exerted by a magnet on a piece of iron is also a non-contact force. Got it? Now we will discuss about electrostatic force. Okay? Activity 8.7. Take a plastic straw and cut it into nearly 2 equal pieces. Suspend one of the pieces from the edge of a table with the help of a piece of thread. Figure 8.11. Now hold the other pieces of straw in your hand and rub its free end with a sheet of paper. Bring the rubbed end of the straw near the suspended straw. Make sure that the two pieces do not touch each other. What do you observe? Next, rub the free end of the suspended piece of a straw with a sheet of paper. Again, bring the piece of straw that was rubbed earlier with paper near the free end of the suspended straw. What do you observe? No. Here, figure 8.11, a straw rubbed with paper attracts another straw but repel it if it has also been rubbed with a sheet of paper. Got it? Next, a straw is said to have acquired electrostatic charge after it has been rubbed with a sheet of paper. Such a straw is an example of a charged body. Got it? Next, the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. Got it? The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. The electrostatic force, therefore, is another example of a non-contact force. You will learn more about electric charges in chapter 12. Got it? Now we will discuss about gravitational force. You know that a coin or a pen falls to the ground when it slips off your hand. Leaves and fruits also fall to the ground when they get detached from the plant. Have you ever wondered why it is so? What? When the coin is held in your hand, it is at rest. As soon as it is released, it begins to move downwards. It is clear that the state of motion of the coin undergoes a change. Can this happen without a force acting on it? What? Which is this force? What? Objects or things fall towards the earth because it pulls them. This force is called the force of gravity or just gravity. This is an attractive force. The force of gravity acts on all objects. The force of gravity acts on all of us all the time without our being aware of it. Water begins to flow towards the ground as soon as we open a tap. Water in reverse flows downwards due to the force of gravity. Got it? Next, gravity is not a property of the earth alone. In fact, every object in the universe, whether small or large, exerts a force on every other object. This force is known as the gravitational force. Now we will discuss about pressure. What is pressure? Pressure. Is there any relation between pressure and force? What? Let us find out. Try to push a nail into a wooden plank by its head. Did you succeed? What? Try now to push the nail by the pointed end. Figure 8.12. Could you do it this time? What? Here, figure 8.12. Pushing a nail into a wooden plank. Got it? Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? Do you get the feeling that the area over which the force is applied, for example, the pointed end of the nail, plays a role in making these tasks easier? Got it? Next, the force acting on a unit area of a surface is called pressure. Pressure equal to force by area on which it acts. At this stage, we consider only those forces which act perpendicular to the surface on which the pressure is to be computed. Next, I know, understand why porters places a round piece of cloth on their heads when they have to carry heavy loads. Figure 8.13. By doing this, they increase the area of contact of the load with their head. So, the pressure on their head is reduced and they find it easier to carry the load. Got it? Here you can see that a porter carrying a heavy load. Got it? Note that the area is in the denominator in the above expression. So the smaller the area, larger the pressure on a surface. For the same force, the area of the pointed end of the nail is much smaller than that of its head. The same force, therefore, produces a pressure sufficient to push the pointed end of the nail into the wooden plank. Can you explain now why soldier bags are provided with broad straps and not thin strap? What? And why the tools meant for cutting and piercing always have sharp edges? Got it? Next. Do liquids and gases also exert pressure? What? Does it also depend on the area on which the force acts? What? Let us find out. 8.9. Pressure exerted by liquid and gases. Here activity 8.8. You can look it. Got it? You can look it activity 8.8. Got it? And next here activity 8.9. Okay? Activity 8.9 you can got it and go through. Okay? Here figure 8.15. Got it? Activity 8.10. Here note that the rubber sheet has been fixed on the side of the container and note at the bottom. Does the bulging of the rubber sheet in this case indicate that water exerts pressure on the sides of the container as well? What? Let us investigate further. Activity 8.10. Got it? Here figure 8.16. Okay? Can you now say that liquid exerts pressure on the walls of the container? What? Do gases also exert pressure? What? Do they also exert pressure on the walls of their containers? What? Let us find out. I have seen fountains of water coming out of the leakage joints or holes in pipes supplying water. Is it not due to the pressure exerted by water on the walls of the pipes? When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of an inflated balloon? Suppose you have a balloon which has holes. Would you be able to inflate it? What? If not, why can we say that air exerts pressure in all directions? What? Do you recall what happens to the air in the bicycle tube when it has a puncture? Do these observations suggest that air exerts pressure on the inner walls of an inflated balloon or a tube? What? So we find that gases too exert pressure on the walls of their container. 8.10 atmospheric pressure. You know that there is air all around us. This envelope of air is known as the atmosphere. The atmospheric air exerted up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. We know that pressure is force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the force of gravity on their air in this cylinder is the atmospheric pressure. Figure 8.17. Got it? Here, figure 8.17, atmospheric pressure is the force of gravity on air in a column of unit area. But how large or small is the atmospheric pressure? What? Let us get an idea about its magnitude. Here, activity 8.1. 1. Got it? Figure 8.18. You can go through it self. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmospheric acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. This activity might give you an idea about the magnitude of atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the. Got it? Next, surface. If there were no air at all between the sucker and the surface, does it give you an idea how large the atmospheric pressure is? Okay. If the area of my head were 15 centimeter into 15 centimeter, how much force air will exert on my head? What? The force due to air in a column of the height of the atmospheric and area 15 centimeter into 15 centimeter is nearly equal to the force of gravity on an object of mass 2 to 5 kg by 150 Newton. The reason we are not crushed under this force of gravity is that the pressure inside our bodies is also equal to the atmospheric pressure and balance the pressure from outside. Got it? Did you know? You can go through it. Got it? Here figure 8.19. Okay? Now we will discuss about what you have learned. First, force could be a push or a pull. Next, a force arises due to the interaction between two objects. Next, force has magnitude as well as direction. Next, a change in the speed of an object or the direction of its motion or both implies a change in its state of motion. Next, force acting on an object may cause a change in its state of motion or a change in its shape. Next, a force can act on an object with or without being in contact with it. Next, force per unit area is called pressure. Next, liquid and gases exert pressure on the walls of their container. Next, the pressure exerted by air around us is known as atmospheric pressure. Got it? Here is some keywords. You can go through itself. Thank you friends. Thank you so much for watching this video. Radhe Radhe.